Morning, everyone. Let's wait another 30 seconds before we get started. All right, well, let's get started. Good morning, good afternoon, good evening, everybody. Welcome to Karmada bi-weekly meeting. Today is October the 31st. We'll take a look on our agenda. And today we're going to have Bloomberg talk about their requirements. And I'm going to hand it over to second. Sorry, who's from Bloomberg? Is that you, Yao?
Yeah, it's me. So
Okay, cool.
yeah,
Would you mind to give us a brief introduction about yourself, your team, and your requirements?
yeah. So hi, I'm from Bloomberg Training and Notebook Runtime team. We are in the Cloud Native Computing Runtime organization. So under that organization, we have Spark Runtime team, Training Notebook Runtime team, and also Flink. We are all like the runtime teams. So and then Kevin, he is also from Bloomberg. We are in the same organization, but he is in the managed compute team. So managed compute means like they will manage all the cluster metadata or network policy and resource code, all those like resources. Yeah. So do you want to share screen? I put our requirements on the agenda. We have a whole list for.
Okay. Thank you. Thank you, yeah. Thank you, Calvin, and welcome. So you want me to share the screen or you would like to share the screen?
Maybe you can, if you have, because I'm behind I'm behind VPN. Yeah, so we list our requirement here. So basically we're looking for a federation API tools, like to help us manage multiple clusters. And we have, we specify like both of them like batching job. And the Flink is a little bit different. It's like a long running job. You can think it's like a long running server there. And for the training and notebook, we really need the extended resource support. So I think I raised the issue like the resource model doesn't support the GPU resource, and it will cause some fragmentation for GPU resource fragmentation. So, and other two teams, they don't need the GPU. So, and then we also want to have an easy way to manage the multi-clusters. We can easily register and deregister the cluster. And then when the cluster is tagged or like cordon, I hope it can be quickly picked up by the Federation API, the Federation management tool. So, and then we do need a customer resource because we have like customer resource defined like in BB. So we have our own compute job and Spark job and Flink job. And inside that job, we have resource definition. So currently we can use a webhook to interpret that resources defined in the job. Yeah, and then we also need a failover and also need a reschedule requirement. I think most of them can be achieved by Karmada. So, and for the resource quota, one team need federated resource quota, but the other team will want instead of federated resource quota, we want to have a global resource quota instead of like duplicate the resource quota for each cluster. Yeah, and for monitoring, we want to have a unified UI for us like to check to check the change log for cluster register and deregister, and also check the cluster resource. Yeah. So this is the feature requirement. And
But before you move forward, I
Yeah.
just want to take a second and see if any like input from Karmada team, that anything we want to discuss from there, from here. I have to tell you, Hong Cai, do you have any comments regarding the requirement? I didn't hear anything.
I think he mute he mute himself. So
Oh, okay.
So so our current main issue is like the extended we really need the extended resource support. And then we haven't POC the DR like the cluster sorry
Disaster
like the
recovery?
failover. Yeah.
I think that's your follow-up questions addressed here. Okay, you can move forward. I don't hear anything from Hong Cai. Yeah.
Yeah, but yeah, if he's not like available now, maybe we can catch up like offline. It's also okay. And then that is our that table shows our feature requirements, and we also have some stability requirements from Karmada. We want to know how Karmada handle failover, because it has to align with our Bloomberg disaster recover. So our requirement is like, if one data center is down, is it easy to recover Karmada on the other data set that all the application team, they couldn't fill the downtime, and then they can still submit the jobs from Karmada, and then the whole, I mean, Karmada, for my understanding, is not stateless. Like all those state will be like transferred to the other data center. Like people, they don't feel any downtime. And what is the monitoring and the metrics, and for scheduling and descheduling, do you have any benchmark? Because we don't want Karmada to be a bottleneck for our job submission for multi clusters. Like, yeah.
For your first question, I think there is a feature gate in propagation policy, which is failover, and it's enabled by default. If you have that feature flag enabled, we can follow over the workload to the other like member clusters.
No, it's not.
It's not the same.
Yeah, it's about the Karmada itself. I mean, if the Karmada, like the Karmada control plane, the scheduler, the control plane is totally down, or for the cluster where I run the Karmada is totally down, how I can recover from that?
Oh, you mean the Karmada cluster?
Yeah, it's more like yeah.
And monitoring metrics, I feel like there's a page in their website seeing how we do the metrics monitor. We ever log into this page and see how it worked for Bloomberg?
Yeah, could you help like put that link in the agenda? Then we can check later. Yeah. Okay. Yeah. Thank you.
Benchmark, and I think that also mentioned in one of their blog or in this page. Let me search. benchmark. I'm so sorry about the background noise. I think they have a performance test for Karmada, and there are a couple of like output here. But I'm gonna also
The performance test data.
report. Okay, thank you, Xingyan. All right, this is the one.
Oh, yeah, I see
This one also take like
the
okay,
test report, right? Yeah,
cool.
that's cool. Yeah.
And Hongzai, I think I hear you. Okay, I'm just gonna read this loud for Calvin. And Calvin has a question about is how do you define the data center? If you have AZ level latency between data centers, it's easy to set up multi-AZ control plane for Karmada.
Let me see. How do I define? Oh, so it's more like the data center like located like in different physical location. Is more like usually we have like two data center for one tier. You can think like for example for our depth tier, we also have a like two data center located like in different places. So I don't think the latency, the data center latency is a matter here. The problem is like how could we get how could Karmada get recovered if one data center is down? So we so for example we can run Karmada on two data center and maybe pick one data center as the master and the other one is like the backup. The problem like is the master if the master Karmada if that data center is down, how could we transfer those state to another data center? I mean, to the backup Karmada, which is running on another data center, and then all the control plane can be recovered, and also the backup Karmada also have all the registered clusters and all those jobs. It's more like how we can like transfer those states to the backup Karmada. Yeah.
Calvin, did that answer your question?
Hello, can you hear me?
Yeah.
Yes.
Yeah, so you know that if you have a very low latency, basically it's easy to set up a multi-AZ HCD cluster.
Mm-hmm.
Then your state of the state of the Karmada control plane is kind of up to date between the HCD nodes.
Okay. So it's more like I remember the project is more it's kind like for the
So Karmada today use etcd as the backend to store the cluster status. So
mm-hmm.
it's very similar to set up the control plan, just like you set up the control plan for Kubernetes.
Oh, I think I get your point. It's more like if my XCD is like can achieve our like DR. For
Yeah.
example, if I have I think that will solve the problem. If I instead of XCD we can run Postgres for in two places and like sync the data there. So yeah, I think that will then we probably can use this one, the kind, right?
Mm-hmm. But my point is that if you can deal with the HCD, it's kind of already supported.
Oh, okay. But I think I get your point. It's more like we have XCD like deployed into data center and make sure the data are like are synced
Thunderbolt connector.
between the two data center, right?
Yeah.
Full power? No, I think the off of my Mac. I think this is a Windows connector, right? I can't get the screen. Yeah, this came like this, right?
I think another main issue for us is like the GPU resource support. I hope it can be included in the in your resource model, and then maybe also support other extended resource. That is like our main issue now. So and then I think in our next step, I only POC the main function, like use Karmada to manage multi clusters and submit a job, very simple job, a very simple customer define customer, sorry, a job with customer resource, and then I think in the next step, maybe we can POC the cluster failover and the cluster taint.
Cool, that sounds good. And I think you have also mentioned.
Yeah, this is
Okay.
our. Yeah, this is our the underlying is
Or you're
like
using
the
this training operator in.
the
Okay.
underlying is the Python shop and the like training operator. Yeah. And then I remember Karmada now is like the CNCF incubating, like it's graduated from Sandbox. Is that correct?
Oh, yes, that is
So-
correct.
Well, so it's now in the incubating process, or what's the current status?
So we already got approval from the CNCF that from the TOC that it's now an incubating project.
Okay.
And we are gonna discuss this requirement offline, the resource model. That's the first extended resources.
Yeah.
Okay. Just want to double check or your requirements has been addressed. Okay, this is for the next POC, the cluster failover.
Yeah, the cluster failover and the taint will be
And taint.
our next. Yeah. Oh, another thing is for the resource quota, and is that possible to support a global resource quota? And then for the federated resource quota, is that okay to? I think it's still in alpha stage, right? It's like experimental things. When it can be big, when do you think it can be like stable?
Anyone from Karmada team can confirm this? Global resource quota.
Yeah, and then for monitoring.
Maybe for the next time. Sorry.
Yeah, maybe next time.
Yeah.
And then yeah, we also
Yeah,
need a good UI tool.
Yeah, just some quick reply. So for the global quota, you need to be you need more kind of data, I mean, about your network and the latency, because every request would go to a kind of single point to check the quota. So we need to be careful to implement that. But it's actually quite easy. You can kind of implement it with admission webhook by yourself. And we have also discussed that just not yet implement that, but the implementation should be very easy. Yeah.
What do you mean by the latency? It means like you need to talk directly to the API server to get the resource quota for.
You know the resource quota is it's like a filter to kind of check every request if the request will
Yeah,
cause any usage kind of exceed the quota, right?
it will. You mean it will affect scheduling, right? Yeah.
No, affect the API call. For example, I want to create a pod or create a deployment.
Yeah. Then.
So
Mm,
for example, if you want to set a global quota to limit the number of pods, right? You need to add a admission webhook to every underlying member cluster to kind of check the pod creation and calculate the summary of all the pods under a certain namespace if they have used up all the quota or not. So that API call, we think that we think it's kind of effect on the API call latency. Yeah. So also because your the quota checker is kind of need to be running as a microservice, right? So you need to make sure if the network latency is okay and the quota checking microservice are able to uh, kind of return the API call in a very short time. Yeah.
Okay. Yeah. I need to think about like your comments, but maybe I will ask you more question about that.
Sure.
Yeah.
All right, you can open an install in the Karmada upstream, and maybe we can follow up there.
Yeah. I think we have a Slack channel in CNC app.
Okay.
For us. Yeah.
That's great.
Question there. Yeah.
Change log. Okay. So monitor and
For UI. I think we can have, so those metrics are great, but we still want to have that nice UI as you guys have now. So maybe add more feature there. Yeah.
so you want to use this Karmada dashboard UI and
Yeah, we want to. Yeah.
what kind of feature you want to? Sorry, I just want to make the meeting notes.
It's kind of like show us the change log of cluster register and deregister, and also if you can also support extended resource on the UI, that would be great. And then and I don't know if you have any plan like to allow user to use your UI to register and deregister the cluster.
Or what the other request is about the resources? Resource quota?
Yeah, extended resource code display on the UI.
extend the resources display. Okay. Right, I think we've already went through everything. And for the cluster failover and federated resource quota, and also the metrics monitoring the dashboard UI can be discussed in the next meeting.
Yeah.
Cool. And any other questions from our audience?
Hi, I just have a question about the scheduling part. So, could you tell a little bit more about what kind of job you are running on top of it? Basically the training and the Spark runtime, right? And also Flink.
Flink, yeah.
Yeah. Do you have a number from your team that like how frequent the objects will be created?
Oh, I cannot say for Flink, but I will gather some data, those number for you next time. For training and runtime, for training, it's not that frequent. Usually, people just submit very like long time training job and usually take the whole node or even the whole cluster. So we don't worry too much of that. And then for Spark, I can give you the number for Spark and Flink. I don't think Spark has, yeah, I can give you the number next time, but I still don't think Spark is heavy load. But the problem is like the the Spark can has multiple executor pod. So it's mainly for one Spark job. It can schedule like 100, not 100, maybe 50 execute pod or even 100 execute pod. And those execute pod need to be guaranteed to schedule on the same cluster because we don't have cross cluster like network. We don't, yeah. The cross cluster traffic it's not allowed. Yeah, from our side, yeah.
Yeah, I think it would be kind of interesting topic to discuss more about the model of Spark running kind of on top of multiple clusters. You know that in the single cluster it's quite easy and quite clear, but in the in the Karmada case, one of the topic, I mean, one of the question is, shall we kind of run most of the Spark job related to one kind of uh, the process data process into one cluster. You know, if they have some relationship between different parts, and
Yeah,
then which API server it's really talking to, it's kind of very interesting. Shall we make it talk to the underlying Kubernetes API server, or we make every Spark? I mean, we make every API core from the Spark talk to the Karmada API server. So that's a very interesting topic, and that affects the whole performance a lot, I believe.
I think I I can talk briefly about our Spark job. So our Spark job is more like so the underlying is like one driver and the multiple execute pod scheduler, and then the driver talk to each execute pod scheduler. So that is how this group of pods works. So and then that is why we cannot schedule those multiple execute pod scheduler to different clusters because they need to talk to the driver. Yeah. I think it's maybe a little bit different than from what you have described for the Spark job, like maybe running on your cluster.
Yeah, I think we may need more time to discuss about this, and we also have other users have discussed about the running Spark on top of Karmada. I think maybe they have some little bit difference. Yeah, and we want to collect the most of the requirement and see how we can provide the best practice.
Okay. I can get you the number of the loads for our Spark cluster, and then maybe I can draw some very simple diagram to explain the architecture behind it.
Yeah. That would be very helpful.
Okay, cool. And any other questions from you, Kevin? No more questions?
No, that's
Hey
all from my
guys.
side.
All right.
Hey guys, can you hear me? Can you hear me?
Yes.
Yeah.
Yes, I can hear you.
Yeah. I want to share some experience with you about the scheduling of Kubeflow training job because we have some clusters and they consist of a lot of NVIDIA GPUs and we have a lot of Kubeflow training jobs running on these clusters. So maybe I think my experience may help you, I think.
Yeah.
In my clusters, yeah. So we use Karmada to manage these clusters. We have maybe about 10 clusters of these GPU cluster. So but the users they submit the training jobs into Karmada control plane but we must make sure the job all the replicas in the job should be scheduled to one single cluster as you say just now, like the Spark job. So you can not divided these not divided these replicas. So in my opinion, currently Karmada may not have this capability to make sure these CRD, these training job CRD could be scheduled to one single cluster. So I try to modify the source code of Karmada in our production environment. So the scheduler could notice the Kubeflow training job CRD and they just retrieve the source request of the pods and the templates from the job CRD, and the scheduler know how many resources the replicas request and how many replicas. So, and according to the estimator, the Karmada estimator, and the scheduler try to schedule these jobs in one cluster. So I just do some updates, but the source code has not been cherry picked to the Karmada
Mhm.
community source code. So
But
yes.
Yeah, in my POC, I try to use the webhook. Do you think what's the difference between using the webhook? They have the webhook to interpret the customer resource.
Mm-hmm.
What's the
Mm-hmm.
difference between user webhook and the native support by Karmada? Yeah.
Okay, so you use the Karmada interpreter webhook, right?
Yeah.
Okay, so I guess Karmada interpret webhook is used to interpret the resource, the template of the something like the deployment or this but it cannot interpret the multiple resources, right? Because in the training job, like MPI job or Python job, you do have the launcher and worker. They may have different resources, right?
Oh, I think I got your point. Yeah, that's the limitation because I need the individual one. So currently it works because our cluster, I only try very simple two worker job. Yeah. It should know the granularity in the pod level.
Okay.
I need to double check my interpreter. I think I kind of like get your point. 1 second.
I got you. So your launcher and your worker, they do have the same resource requester, right?
Yeah.
Oh,
I mean the master
work.
Yeah, that can work because in my case the master and we force the master and worker, like they have exactly the resource request and limit. So
okay, so but I think Karmada could not make sure the job could be scheduled in one cluster, right?
So for the policy, I think I post that in the issue. 1 second, let me find the policy. I need to check my policy again, but I remember I forced that to one cluster.
Oh, I think you use the spread constraint, right?
Yeah.
Oh, okay, I got you.
Yeah, I don't know
that
if
might
it
works.
I don't know if it is recommended by Karmada, but currently, like in the POC, it works, but we haven't do any load testing, stress testing. So.
Okay, I got you. It could work, I think, if you have the limitation like the resource of launcher and worker, they should be the same. I think it could work.
Yeah, but it's also great if Karmada can support Kubeflow, like natively support Kubeflow. Yeah, like training operator, customer resource, then we don't need to worry that too much. Yeah.
It makes sense because Kubeflow is really popular in this AI training scenario. Yeah.
Thank you so much, Gary, for sharing your experience with us. And for the thing you just discussed, are you going to open an issue in upstream to let Karmada to support the Kubeflow? Or there isn't an open issue there?
Maybe not. I think we can open a new issue about support the Kubeflow training operator.
Awesome. Take the note.
I have another question about this topic. So we cannot divide the replicas into across different clusters. So which how do you choose which cluster we can dispatch the MPI job, TensorFlow job, whatever? So which how do you choose which cluster, and how can you guarantee that all the pods can be scheduled successfully in that cluster, because we need the gun scheduling capacity? Can you share something about this?
Yeah, because you see, we have the Karmada estimator, scheduler estimator. Yeah, so the scheduler estimator could try to estimate the scheduler results according to the resource request of this Kubeflow job. So I think according to this scenario, the limitation, the resource limitation of the launcher and worker, they are the same. So we can consider this job as kind of something like deployment, but all the replicas of this deployment should be scheduled to one single cluster. So I think for sake of the help of the Karmada estimator, so we can try to simulate the scheduling process. Yeah.
If I understand correctly, so it's decided by the estimator, right?
Yes. Yes.
Okay, good idea. Yeah.
等一下。
All right, and any more questions? Okay, I'm gonna take this silence as no, and that seems like this is the only topic on our agenda for today. Anyone else have any things wanna talk about? All right, I just want to read this chat from Hongtai. Yes, this makes sense for Karmada to support Kubeflow jobs better, especially you can interpret the resources required by mastery and worker. Cool. And all right, this is gonna bring us to the end of this meeting. And thank you so much, everyone, for joining this Karmada bi-weekly meeting. And I think I've already catch up most of the things that I want to discuss for the next time. Maybe next time we can go deeper into some of the resource quota, metrics, failover. Yeah. Cool. And thanks everyone again for joining. I will see you next time.
Thank you.
Thank you. Bye.
Yeah, thank you. Bye.
Thank you.
Bye.
Bye.